Hello students, we are continuing with chapter 13, Game Theory and Strategic Competition, and in this video we focus on entry deterrence. Entry deterrence is when you have incumbents in the market, which could be one firm. In this case we look at a simple model, one firm incumbent and another firm wants to enter the market. So to deter entry, the incumbent firm must convince any potential competitor that entry will be unprofitable. Now let's look at this case. The incumbent has a has dominant strategy. So let's start 100 and 270 and 130. So incumbent has a dominant strategy at high price. Okay, potential entrant 20 and negative 10, 0 and 0. If they stay out, they get 0 lah. So they do not have a dominant strategy because there's no clear advantageous position line to take. Alright, if the potential entrant enter and incumbent is being nice to them, being accommodative to them, then the equilibrium will be here. Potential entrant enter and the incumbent decides to be accommodative, then this will be the outcome. But if the incumbent says no, we're going to fight you to death, then they will just charge a low price, okay, to undercut, to make the entry unprofitable for the potential entrant. So this will be the warfare decision. Okay, so the result here will be potential entrant will be scared away from the market. Right. Again, the question is credible or not. If it is credible, then stay out. If it is not credible, they don't want to lose their profit to 70, then you have a chance to enter. Now, the incumbent can make its threat very credible by committing to something, that makes them look even more fearsome. That shows their commitment and intention to fight the war to the end. So let's say they committed to a 50 million additional capacity, with a new plant or something. So that is a commitment. So even if they have to lose their profit, so now their profit is 50. 200 now becomes 150. So let's see whether that is enough to deter. So the case here is that the incumbent will have, by looking at this, the incumbent does not have a dominant strategy, because it's almost the same, but the potential entrant will not have a dominant strategy either. Okay, that's how you start. So what's the choice here? If they enter, they get 20, accommodative, but it looks like they are not being accommodative because they made their commitment, and so they are going to go all out. They're going to choose warfare regardless. So the outcome will be 10, 70 and 10. So in that case, this credible threat, so potential entrant do not enter, and when they do not enter, the final outcome will be 120 and 0. Okay, let's use this kind of analysis on international competition. You have two companies. Airbus is Europe Boeing is US. Okay, and both of them wants to develop a new aircraft, but they know that their profit is dependent on what the other company will do. Okay, if both of them produce new aircraft at the same time, then they will lose. But if they don't produce, they will gain nothing. Okay, so the only Nash equilibrium they can possibly hope for is Airbus produce, Boeing does not, or Airbus does not produce and Boeing produce. Okay, so there are two Nash equilibrium, which is only one company will produce the new aircraft. Okay, and it depends on who can produce or who can commit first, right? Now, imagine a situation where the European government decide to give subsidy to Airbus. Okay, and the subsidy is 20 million only. Yeah, even a small subsidy, how does it change the situation? So remember just now, if there's a subsidy for Airbus, then the loss here, the negative 10 loss here, yeah, will become plus 20. So because you got subsidy, your loss is covered, and you get an extra 10 in fact. Okay, same thing here, you get an extra 20, so now it becomes 120. If Airbus produce, they receive a 20 million additional income as subsidy. So therefore the loss now, their position now is negative 10 plus 20 is 10, and then 100 plus 20 is 20. Okay, so this is the new table. So what's the best outcome for Airbus? Now Airbus will have a dominant strategy at 10 and 20. So this is dominant strategy. And Boeing has a dominant strategy of don't produce. You see? Okay? So what is the outcome? The outcome is 10 and 120. Yeah, that will be the dominant strategy with subsidy scenario. Yeah, because that's where both DSs, both dominant strategies are. Okay, chapter 13.8 auctions, you can read most of it, the different types, the definitions, but I think you may have seen from movies, or you may have seen from dramas what auctions are, right? Where you independently, there are a number of bidders independently, non-cooperatively bidding for a product that they do not know the actual value, they just want to buy the product, and that happens when you provide the highest bid. Okay, so let's say the value or the actual value is 620, and because you don't know the value, when you want to outbid the others, so you get people start from offering 450, 490, 500, up to 620, some 670, some 690. And who will win? The person that gives the highest at 690. And the positive error here is, we call this positive error. That means they have overestimated. Okay, they overestimated by 70. So the person who wins is actually the person who has the largest positive error or the largest overestimation, and this is what we call the winner's curse. Yeah, it's very rare that you are able to bid at the right value. Even if you're able to bid at the right value, there will be, you want to make sure that you win, so you will still bid higher than what the right value that you think is, in order to secure that product. Okay, so how to avoid the winner's curse? So normally companies that bid for contracts or that bid for oil, reserve some some license, whatever, they take into account that positive error, and they recognize that there is not just the value, but also the amount of positive error that they are willing to make in order to secure it. Yeah, if they really think they want that product or that location or that contract, then they put in the value of their work. For instance, the value of a work is 100 million, and they also include the value of the positive error, that it could be 50 million plus, in order to make that bidding, in order to get the contract. So the cost to them is 150. Anything beyond that, they will not go. Okay, so what is the amount of positive error that they are willing to take, and that will be their limit to bidding. Okay, but they will use sophisticated methods to evaluate the positive error that they're willing to absorb. Okay, so the rest you can read from the textbook. I will stop here. Thank you very much. That's chapter 13.